Let's calculate this example of a weighted average. Suppose a college class calculates grades based on 2 tests worth 20% each, a final exam worth 30% of the overall grade, 15% is from homework, 10% is from projects, and 5% is participation. This is very typical of many college classes that they would use percentages or a weighted average system. In this case, it says the standard 90 to 100, 80 to 89, 70 to 79, etc., that grading scale is used to determine the letter grade. So in this case, we know anything 90 or above would be an A, 80 to 89 would be a B, and so on. And then we have some scores for a particular student in this class. It says, suppose a student in this class has test scores of 79% and 92%, 100% on their homework, 38 out of 40 points on their projects, and 30 out of 32 for participation. And it's asking us, in this case, what score do they need to earn on the final exam to get an A in the class? So we know that the way that we calculate a weighted average is we take each item's weight times its score, right? So if we just base this, before we even have any scores, if we just base this off of the information of how this is calculated, and you could do this yourself for any class that uses a weighted grade, you could look at the syllabus and see what the percentages are and calculate it. So the first thing it mentions is that 2 tests are worth 20% each. So I would change 20% to a decimal. So if you want to leave it as 0.2 or if you want to put the 0, it doesn't really matter. So I know 20% times whatever test 1, whatever that score is. And then I would add 20% times whatever my score is on test 2. And then I'm just going to go in order here. So the next thing it lists is a final exam worth 30%. So that would be 0.30 times, I'm just going to use F for final, plus it says 15% for homework. So that would be 0.15 times, I'll just use H for homework, plus 10% for projects. So 0.1 or 0.10 times P for projects. And then I'll make that a PR since we're also going to use P for participation. So 5% would be 0.05, and I'll make that PA for participation. So this would be how I would calculate a weighted average. How I would calculate any average in this class is I would just plug in the scores. So let's go ahead and do that for this student. So for this student, it gave us several scores here. So we'll just substitute those in. So it says the student has test scores of 79% and 92%. So 0.2 or 0.20 times 79 plus 0.20 times 92. And then they don't give us a final score. If they did, we could actually calculate the overall grade. In this case, though, that's what we're trying to find. So for right now, I'm just going to leave it as F. So I'm just going to call this 0.30F. And then 0.15 times, they got 100 on their homework, plus 0.10. So for projects, they don't give me an actual score per se. So at least not as a total number of points. They're telling me that on projects, they got 38 out of 40 points. So what we need to do is just change that to a percent. So 38 out of 40 is really the same thing as 38 divided by 40. And you could do that by hand, although we are allowed a calculator in this section. So just to save us some time, we could go ahead and get that. And that's 0.95. And then if you multiply that by 100 or move the decimal 2 spaces, that would change it. So right now we took that fraction and wrote it as a decimal, and we really want to change that to a percent. So move the decimal over 2 spaces. So this is really the same thing as 95%. So 10%, 0.10 times 95, and then 0.05, and we're going to do the same thing for participation. So they got 30 out of 32 points participation, which is really 30 divided by 32. So if I want to change that fraction to a decimal, I would just divide 30 by 32. And I get 0.9375, and then move the decimal 2 spaces or multiply by 100, same thing. And this is really 93.75%. So that's their participation. notice that on all of these that we're leaving the scores per se, we're leaving those percentages as whole numbers, but the values, like the weights for each item, those were actually changing to decimals. So like 20% for the first test got changed to 0.20. 15% for homework got changed to 0.15. All right, so this is how I would calculate the overall average. Of course, I'm going to be a little stumped at this step, right? Because I don't know what that final score is, right? If I did, I'd just plug it in and see what their overall score is. But this is before they take the final. So what I would do here is I could go ahead and do the multiplication on everything else, right? I could go ahead and multiply all of these other ones, and then I could combine those. And then what I'm looking for in this particular case, we're trying to figure out what score do they need on the final in order to get an A in the class. And we know that they're using the standard grading scale, 90 to 100 is an A. So really what we're saying here is we want this to be equal to 90. Or if you wanted to say greater than or equal to 90, that's fine. A lot of times we just go ahead and put an equal sign there because we're basically saying it needs to be at least this score, right? And 90 is the smallest percent they could get and get an A. So we want to see what's the smallest score they could possibly get on the final and still get an A. Or what's the minimum score? All right, so then we're going to go ahead and just do some multiplication and simplification here. And that calculator is going to help speed this up a little bit. So we can do 0.2 times 79. That's 15.8. And then 0.2 or 0.20 times 92. That's 18.4. And then I'm just going to leave this as 0.3 F, or if you leave the 0 on there, it doesn't matter. Either way, it's the same thing. 15% of 100 would be 15. And then 10% of 95, 0.1 times 95 is 9.5. And then 5% of 93.75. Just multiplying those, 4.6875. And then at this point, all of these except for this one are all like terms. So I could go ahead and combine those just by adding those terms together. So I'm going to add here 15.8 plus 18.4 plus 15 plus 9.5 plus 4.6875. And that gives me 63.3875. So that's what I get when I add all of these constant terms together, but then I still have this plus 0.30F, and then this is still equal to 90. So all I did there was just combine some like terms, and now I'm going to solve this equation. So I'm trying to get F by itself. So my first step, if I want to solve this for F, would be to go ahead and subtract this constant from both sides. If I subtract 63.3875 from both sides, I'm going to get 0.30F on the left side. And then on the right side, I'm just going to do 90 minus that. E minus 63.3875. Make sure I type it in right here. So that's 26.6125. And then since this is 0.30 times F, then if I want to get rid of multiplication, I would do the opposite, which is division. So I would divide both sides by the 0.30, which would get F by itself. And then while that's in my calculator, I'll just hit divided by 0.3 or 0.30. And we get 88.7083 repeating. Already forgot it. 7083 repeating. And if it asked for an exact answer, we would give that, but typically we would round it to whatever the problem asks for. If this were a practical situation, this is the minimum score a student needs. I probably wouldn't tell a student that they should get at least an 88.7. I would probably say, you should probably get about an 89, right? An 89 is probably the lowest, and I would aim for a little higher than that, right? So if they get at least roughly an 89 on the final, they should have an A in the class. And then you could do this similarly if you wanted to know for any other grade. So like if you wanted to know what score you needed for a B in the class, that means you would do everything the same here, except instead of making this 90, you'd make it 80, right? If you want to figure out what score you need for a C, you make that a 70, right? So you could do this for any score that you're trying to figure out.